Hi, this is Adam Griffin with the first video for this week. So this is going to be problem number 1, and it deals with tension and density of a cable, and as well as the length to find a few pieces of information about the cable. So it goes like this. So one of the longest spans for a cable car is Giant Glacier on Mont Blanc. Definitely did not say that right. With a total span length of 2,831 meters. The cable has a diameter of 3 centimeters. And for this problem, we will assume that there is uniform tension in the cable close to its maximum safe limit of 110 kilonewtons. So assume the density of the cable is 5,000 kilograms per cubic meter. So we're going to be using all of these things, and there's 4 parts to this question. So we'll start with part A, which is calculating the total mass of the cable between the 2 towers. So we have our cable right here with length 2,831 meters, and we know that mass is equivalent to our density times our volume, and our volume is equivalent to our area times our length. And our area is equivalent to, so we have our cross section right here. We have to find the area of this, which is equivalent to pi r squared. And we have r because it gives us our diameter of the cable up here. And all of these variables are written right here as well. So we can combine all 3 of these, and we get that our mass is equivalent to the density of our cable times the length of our cable times pi r squared. So we can plug all of those in, and we find that the cable has a mass of 3,185 kilograms. And for part B, we're calculating the linear mass density of the cable. So linear mass density is the mass to length ratio. So it's the mass of a meter long section of the cable. So we do that, we take our mass that we found earlier, and we divide it by our length. So 3,185 kilograms divided by 2,831 meters, and that gives us 1.125 kilograms per meter for the linear density. So to find, for part C, we have to calculate the speed of disturbance on the cable. So the speed of disturbance is the speed at which a wave would move through the cable. So we can find the velocity of those waves by getting the square root of the tension divided by the linear density. So we have our tension up here. It says 110 kilonewtons, so 110,000 newtons. We plug that in, divide it by our linear density ratio. Plug that all in, we get that our speed of disturbance is 312.7 meters per second. And finally, we have part D, and it asks how long does it take for a pulse to traverse the span of the cable. So to find that, we have to divide the length by the velocity at which the wave moves, which is pretty straightforward. So we plug that in, we have our length, and then our velocity of 312.7 meters per second. So the time that it takes to travel from one end to the other is 9.054 seconds. This problem mostly just deals with waves, and yeah, that is really all there is to it. So that is how you do problem number 1, and thank you.